Hey there kids, welcome to another video. Now this one is actually for Eureka Math, grade 5, module 2, but it's for lesson 23 problem set. I was looking back and my other videos from my old channel, it has it broken into 2 parts and well, I just want to put it all on one. So the objective for lesson 23, while if you want to watch my other video that has probably some notes on it, this one is just going to be working through the problem set so that we can finish it in a reasonable amount of time because they take kind of a long time when they're longer division problems. The objective is on the bottom. As always, divide 3 and 4 digit dividends by 2-digit divisors, resulting in 2 and 3 digit quotients. That means everything's getting bigger and more challenging, a little bit longer, it takes up more space. We're going to reason about the decomposition of successive remainders in each place value. So, place value matters. First thing I'd like you to do is to section off your book and give yourself some work to work. That's fun. So anyway, divide, then check using multiplication. So we're going to set it up with the bracket and leave room to check over here. Remember that this is the ones place and everything is connected to place value. This is 4,859 divided by 23. I wish I had 20 so I could use a nice round number to get close to this, but it's pretty simple. If you look at your 23 and say, I wish I had 20, then I could do 2040. So I can put a 2 here and know that 2 times 3 is 6, and I will still be underneath my 48. So there's your 6 and your 4, and subtract, and you get 2. You're going to be using the steps of the division family: divide, multiply, subtract, compare, bring down, and we're going to use it over and over again on this video. So 2 is left over. That means 5 can come down. I have 25 that is divisible by 23 one time. 1 times 23 is 23. And let's subtract and get 2 again, but this time we're going to bring down our 9. 29 divided by 23 is 1. Multiply and get 23 again, and subtract and get 6. So place your remainder up here, and this time in this video we're not using decimals or zeros. To continue, we're just going to place our remainder up there and then use our check. Okay, so you're going to multiply the 2 outside numbers. It's nice when they're ones. 3 times 1, 3 times 1, 3 times 2. That's also easy. Hold this spot with the 0. 2 times 1 is 2, 2 times 1 is 2, 2 times 2 is 4. Noticing that your full product here, 3, 5, 8, 4, it no longer matches anything that you're getting because we're having to go through that division step several times. Okay, so you have your 4,853, which doesn't yet match this because you haven't added your remainder. And now that you have 4,859, use an active check to prove that yes, your quotient is 211 with a remainder of 6. And so this is the full answer, and this verifies it. So that's what we're doing today. So set up this one. 4, 3, 6, 8. Okay. And we've got 50 approximately, which makes it pretty easy to count, but 43 is too small, so you got to go all the way up to 436, which means if I had a 50 and I did 9 times 5, I would have 45, so that's a little too big because I have more than that. So an 8 might be a good guess over the 6. Place value matters. This is really like 80 times 52. So 8 times 2, 16, carry the 1. 8 times 5 is 40, plus 1 is 41. Subtract, and you have 20, which is less than 52, so we can bring down our 8. 208 divided by 52. Again, if I had 50, 50, 100, 150, 200, close enough. And we're going to use 4. 4 times 2, 4 times 5. Nothing left over, so use your quotient and do the check. We're going to check using multiplication, only there won't be an addition step at the end. and then hold that, and then 20, carry that over. 5 times 8 is 40, plus 2 is 42. Add them up. 3 and 4, 4,368. Do your quick check, tie it together, give yourself a star, and move on. Okay, so I know these are a little bit longer. Right, 7, 2, 4, 2. All right, so we're going to take apart 7,242 into 34 groups, and you want to know how many of these groups we can get. So I can fit my first digit in the quotient over the hundreds place because 34 can fit into 72. Now if I had 30, I would say 30 and 30 is 60. If I used 40, 2 40s would be 80. But I don't have 40, so I'm going to reason this out looking at that ones place and say, well, if I use 2, and I have 2 times 4 is 8, and 2 times 3 is 6, I didn't have anything to carry over. So I will have enough left over so that I can do that operation. 2 times 3, there's your 6. Okay, so what I want to have is less than 72. So 4 is the remainder, bring down your 4. So I now have 44 divided by 34. It's not just 44. I mean, this is really 68 hundredths when divided by 34, and I get 2. That's really 200. And so when I have this 44, it's really 44 tens, so I can divide 1 time by 34 and use up 34 tens, which leaves me with a 10 left over, or 1 100. I bring down my 2, and I have 102, and this is my last place value position. And I can divide 102 by 34 how many times? 3, 6, 9, 12, or 4, 8, 12. Remember, so you don't want to go over the 102. Consider the 4. So probably the best guess is going to be a 3. 3 times 4 is 12. When you carry that 1, I get 3 times 3 is 9, plus 1 is 10. So you're trying to think about what's the best way to round this number. If I use 30, don't forget to calculate the 4 extra several times. Okay, so we have no remainder. You don't have to put R0. You can just leave it at 213. Set up your check. Start multiplying. 4 times 3, you've got 12. Carry that 1. 4 plus 1 is 5, and then we have 8. Hold that spot with a 0. 3 times 3 is 9. 3 times 1 is 3. 3 times 2 is 6. 2, 14, 9, 10, 11, 12, 7. But that's not our final answer. Oh, yes, it is. Yeah, that is. Oh, and I should put Bob here. Kids love it when I put Bob. We have no remainder, so this is the final answer. Sometimes I just get ahead of myself. Okay, move right along. 3, 1, 6, 4. Okay, so 31 is too small to divide 45 into, so I have to use 316. First digit in the quotient will go here in the tens place. So how many times can I fit 45 into 316? Well, if I use 40, I could count times 7 to get to 28. If I use 50, it would be a little bit less. So I try to think about what I'm going to get if I use that 7 and I have the 5 and I carry it over. That'll be just enough. So I have 35, and look, 7 times 4 is 28, 29, 30, 31. So I'm kind of mentally calculating in my head how close I'm going to be, because I don't want to have to erase this and start over, but you certainly can. What happens here? Notice that if I've broken this down, I have a 14 left. That's not divisible. This is now my remainder. So 14 is not divisible by 45, but you have to hold this place with a 0. Now, we were talking in class about why it's better to put the number with the 0 on the bottom. Makes your work a lot easier when you just go 0 ones times everything is 0. Move over to the next place value position. There's your 35, 28, 29, 30, 31. Then take your remainder, add, compare, star. 3,164. Yay! All right, next one. 29 into 9,152. Okay, so if I have about 30, remember, you just use the numbers so that they help you skip count. So 30, 60, 90. I can use 3. 3 times 9, 27. Carry the 2. 3 times 2 is 6, plus 2 is 8. The difference between this is 4. If you want to use the standard algorithm, you can. Take 1, give 10, and then find the difference there. 4 is less than 29. Bring down the 5. Now I have 45 divided by 29, which if it was about 30, you can see that you can't get to 30, so you have to have 1. Put that over the 5, because that's the number I'm using here. 1 times 29, 29. And then remember that as we take apart each of these pieces of the 9,152, we're removing some thousands here, we're removing some hundreds, we're using them up, and then the digits have to correspond in the place value positions in the quotient. It really, really, really does matter. The reason that I don't put these zeros here all the time is, well, nobody wants to have to repeatedly write a bunch of zeros. If you line everything up in your place value positions, that's the standard algorithm. Okay, so the difference between 29 and 45, you can use the standard algorithm. Let's see, take 1, give 10, there's your 16. And now we can bring down our 2 in the ones because 16 is less than 29. Now I have 162 ones that are left. And that would be, if that was 30, that'd be about to 15 for 5. 5 times 9 is 45. Use a 4. And then 10 and 14. That's about as close as we can get without going over. Use the standard algorithm. 12 minus 5, and we have a remainder of 17. Standard algorithm to check. All right, 9 times 5, 45. 13, and then 27, 28. Next one, hold this with a 0. That is not this one. 2 times 5 is 10. That 0 goes here. Carry the 1. 2 times 1 is 2 plus 1 is 3. And then 2 times 3 is 6. Nothing was carried over. Add these up. 3, 8, 9, 10, 11, 6, 7, 8, 9, 91, 35 plus 17. Don't forget to add your remainder. There's your 12, 3, 4, 5, 1, 9, 1, 9, 1, 5, 2. Compare, check, star. Getting out of breath. Okay. 63. 4, 4, 2, 4. All right, 44 cannot be divided by 63, so you have to go all the way over to 442. 442 divisible approximately, let's say we use 60 times 7 would be 420. We've got a little extra. Let's see if we can make it. Yep, 42, 44, just barely. And again, we've got this 4 that comes down. It is not divisible. We move right on into the check. 63, I'm going to put 70 on the bottom so I don't have to take up very much room. 7 times 3 is 21, 42, 43, 44, remainder 14. Add that on to 4, 4. 4, 4, 2, 4. Yay, that one was kind of fast. Hopefully you guys could see that the whole time. And now you can see it. You can pause the video if I had it off the screen there. Okay, word problems on the back. Trying to keep this all on one video for you. All right, Mr. Riley baked 1,692 chocolate cookies. Yum. He sold them in boxes of 36 cookies each. How much money did he collect? That's another part of the question. If he sold them all at $8 per box. So it always reminds me of, like, what's a tape diagram? How does this help us? Tape diagrams are your friend. 1,692 cookies is going to be your whole. He sold them in boxes of 36 each, so there are 36 cookies in a box and 36 cookies in a box. And then you have to kind of go, well, I don't know, how many boxes do I have? It just says sold them all. So we have to figure that out because ... how many? Don't know. But whatever it is, it's $8 per. Okay, so first thing we have to do, this is a multi-step problem. We're going to have to take all of the cookies, the 1,692, and divide them by the 36 that are in each box. So if I have 36 in each box, 1,692, 16 is not divisible by 36. Go all the way over to here and take your 169 and roughly say if I had about 40, 4 times 4 is 16 and I have extra. So I don't want to get too far ahead of myself. I'll guess the 4. 4 times 6 is 24. Carry the 2. Yes, that'll work. 12 and 2 is 14. So subtract, find the difference. And I have 25 left over, and we're talking still, these are all cookies. And it's not 25 ones, it's 25 tens. And that's what's left over before I bring down. I do a quick comparison. Bring down my two, so I have 252 cookies left to divide by 36 per box. Think about if I had about 40, 4 times 6 would be 24, and I have a little bit less than that. So because I'm going down, so I could do 6, 36, 18, 19. That might be a little low. Bump it up. 7 times 6, 42. 4, and there it is. 21 plus 4 is 25. So little mental math before I wrote helped me to decide between my 6 and my 7. There are no remainders. That means there are no cookies left over. And so how many it would be here? Let me change this. We know that there are 36 in the box. We just don't know how many there are. 1, 2, 3, 4, ... How many? We know that there are 47 boxes. And when the lights come on, we'll label the boxes. Now we're going to take those 47 boxes and we're going to multiply them by the $8 per box. So 8 times 7, 56, and 32, and 5 make 37. $376 would then be collected. Okay, so multi-steps, but those tape diagrams can really help you. Next one, also challenging. 1,092 flowers are arranged into 26 vases with the same number, so we know this and we know this, in each vase. How many flowers would be needed to fill 130 such vases? So you could make a tape diagram. It would look a little bit different. We do still know the total. And what we don't know is how many are in the vase, but we have 1, 2, 3, ... and we have 26 vases. So last time we knew how many were in, but we didn't know how many there were. This time we know how many we have, but we don't know how many are inside each vase. So same idea when you know the total, but you don't know one of the parts, you can do division to solve. So set up your total and divide by the 26. Now 10 is not divisible, so you have to use 109 tens divided by the 26. Okay, so the first digit in your quotient goes in the tens place. Imagine you had 30 and you did 30, 60, 90. You could get either 3 or 4 in here. So you have to think now about the extra 4 that you didn't have if you rounded up to 30. Okay, and so if I think, that could add up to a lot, I can put my 4 here and go 6 times 4 is 24, carry the 2, and then I have 8, 9, 10. So I have just enough, okay, because the 24 and then 8, 9, 10. See how I have just enough with 5 left over. Bring down my 2, and then 26 goes into 52 how many times? And you might recognize that it goes 2 exactly. 2 times 6 is 12, carry the 1, and then 2 times 2 is 4 plus 1 is 5. Yay, Bob. Okay, so 42 what? 42 flowers in each. So, but go back to the question, because how many flowers would be needed to fill 130 vases? So now if I know that there are 42 and 42, and 42. How many flowers? This top number is going to change. If you know that you have 130 vases with 42 in each, 42, 42, 42, all the way to 130. One, da, da, da. Okay, this is now what's missing. So how do you do that? Well, when you know both of the pieces, but you don't know the total, then that's the standard algorithm for multiplication. So set that up. 2 times 0 is 0, 2 times 3 is 6, 2 times 1, 2. Hold this spot, move to the 4 tens. 4 times 0 is 0, 4 times 3, 12. 4 times 1 is 4 plus 1 is 5. 5,460 what? Flowers. Flowers are needed. Put a little comma there if you like, and then make sure you label with words. Okay? All right, last one. The elephant's water tank. Okay. The elephant's water tank holds 2,560 gallons of water. I like to draw the big tank, and it's right here. And the top would be 2,560 gallons. After 2 weeks, the zookeeper measures and finds that the tank has 1,944 gallons of water left. So if the elephant drinks the same amount of water each day, how many days will a full tank last? Well, we need to pay attention to the amount of time that has elapsed, because when we have this full tank and then the elephants drink water, this is over a 14-day period, which is equal to the 2 weeks. And so we're looking for this daily rate, which we have to figure out first before we can figure out how long that full tank will last. So step 1, what is the difference between the total and the amount that we have now? That's what we have to do first. So step 1, subtraction. So standard algorithm, take 1, give 10, 10 minus 4, 6, 5 minus 4 is 1, 5 minus 9, can't do, take 1, give 10, give yourself 6, and you end up with 616, this is all gallons, of water that was used up in the 2 weeks. Okay, so take that amount. Okay, so this right here, this number is 616 gallons. But I need to know the daily rate. So I want to do for step 2, take the days and the amount, divide those two, label this. It's 14 days, 616 gallons. And then this number is going to be the gallons per day so that we can figure out about that full tank. So start your division. If I had like 15, I would do 15, 30, 45, 60. So I would give myself 4, and I have just less, so that should work out fine. 4 times 4, 16. 4 times 1 is 4 plus 1 is 5. Subtract and find the difference between 56 and 61. I don't really need to do the standard algorithm because I can just count in my head. And then that's 5 left over, bring down the 6. Look at what we just got. 4 times 14 was 56. So I can put a 4 here and say 4 times 14 and get 56 again and have nothing left over. So take your answer. 44 gallons per day. Let's look at the full tank and set that up with your gallons per day. Per day, those ran together, all the gallons together, and then find out how many days this will last. So 44 will not fit into 25, so we're going to bump all the way over here to 256. You could use, say, 50 and guess or skip count by 5. We actually have kind of a lot less, so you might want to count by 40. 40, and then you could probably get Let's do 4. 4 times 4, 16. No. That's too small. 5. 5 times 4, 20. 22. That's better. Subtract. Yep. Okay. So we have 36 left over, and then that's less than 44. Bring down your 0. And again, we're taking this apart. This is actually 2,200 that we've used. We're down to 360 gallons left. Divide it by 44. Again, if I had 40, I could do, it would be less than 9 because that would be over. So I'm going to bump down to 8. 8 times 4, 32. Use a 3 here. And then 32, 3, 4, 5. Now, what's happening here? The difference between 52 and 60 is 8. So, that's some water left over on my days that the tank will last. So I'm trying to find the days. But what happens? How many days will a full tank last? There's a little extra, but you can't say it's going to last 59 days. So it's 58 days because on the 59th day, you have to start filling it again. Okay, so the tank will last 58 days, and then you'll have like just a smattering of water left at the bottom. Anyway, hope these videos are super helpful for you guys. Again, I've got my old Laura Sutness channel that had this set of videos broken into 2. And so if you want to see the notes, I probably still have the notes on there, but hopefully this was helpful having everything in the same place. Yay! All right, we'll see you on the next video. Bye for now.